Okay, there we go. Recording's on. Okay, so we've added things up before. How did we keep track of what we were adding up? Yeah. Okay, so right. So we used a loop because there was some math we just kept on doing over and over again, and that seems like what we're going to be doing here, because we're going to just be finding areas and multiple and it's going to be of the same shape. It's going to be the same. It's going to be the same formula. We're just going to do that over and over again. We're just going to add things together over and over again. So this is so you're absolutely right. This is a perfect candidate for a loop. We kind of got an idea of the math that we have to do. And we're going to have some variable in that loop that we just continually add the new area of each new rectangle to. So let's see if we can do that. So begin integration. I could use a while loop, that's fine. Could use a for loop, that's fine. I'm going to use a for loop. So let's say for I in range. What should I use for my range? Say again. Okay, and then go in intervals of 0.1 or whatever my dx is. That's a great idea. That is a great idea, and I wish Python would support it. Remember, the problem with for loops is that this, which is called range, has to be an integer, which is really annoying for times like this. So in this case, you know that n rectangle, the number of rectangles that you have, that's the number that's how many times you want to run through the for loop, right? That's how many rectangles that you're going to be adding up. It's an indirect way of doing what you're saying, but it's kind of all that we got. Yeah, unfortunately. So, if that's what we got, how do we use it? How do we figure out what our x value is each time? Assuming, say, that we're doing the right side estimation. So your rectangle, you gauge the height from where it hits the function on its right side, or how we wrote it out here. So you have the function, you have the rectangle. The height of the rectangle is based on where the right side hits the function, or if I know what x value I'm on, and I find kind of the right side of that rectangle, and find whatever the value of the function is at that right side, and that's my height. So how do I do that? How do I get the x that I need? The width would be dx. Yep. So we can just say width equals dx. How do I get the height? Function. Okay. What do I put into function? So say again. Okay, well, if I put in the dx, if I pop back over to if I put in the dx, in this case, it'd always be 1, right? But I need the function when x equals 3, or something like that, or whatever. So the question is, what do I do? How do I figure out, well, how about this? What's my first x value? Well, I'm doing a right side. 1 or dx, right? That's my first one. In this example, yes, it's 1. The second one is 2, or it's 1 plus what? The first x plus the interval, right? So the first x value plus dx gets my second value. Second value plus dx is my third value. Someone said something about I. I, okay, what's I? How are you tying it in? Okay, great. So if I was looking at this, that'd be perfect. That'd be perfect because x is going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, 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 blah. Here, I'm not necessarily moving by steps of 1. I'm moving by maybe a 0.1 or something like that. How do I use I to drive that? Because you are right. It's moving in. Let's call it, if I can think of how I can relate I to x values, that's like gold. But how do I do it? How many dx's have I moved when I get to 2? 2. How many when I get to 3? 4, and so on. So I can use I as kind of a multiplier, because I know because it's just kind of keeping track of how many dx's that I've moved. And I know where I'm starting from. This is a right side estimation, so I start from my first dx. So I can come over here. I can say my x location is dx plus dx times I. I is going to start at what value? Not in this case, 0. It starts at 0 because I don't have anything else specified. So if I starts at 0, dx times I is 0. I start at my first rectangle on the right-hand side. And then I keep adding 1 dx to that every time that I go through this loop. Perfect. So I have my x location. I just need to get the height at that x location, which, as said, is just func. Evaluate at the x location. And then I can find my area and sum all that up. And as said, we need some variable to sum everything up in. So I'm just calling it total area. I'm initializing it to 0 prior to the loop, because else it's just a big bundle of crap, and it just reinitializes itself with every iteration. So I'm doing it right before the loop, and I just keep adding the new area to that total area and updating the value of total area. Any questions about this? Make some amount of sense? Now there is one trick to this game. We need to make sure we need to make sure that it's actually doing the right number of x values. That's actually hitting all the x values that we want from 0 to 10. So let's just do a quick check of that. We could probably go through and reason it out, but often it's just easier to do this. I'm just going to print dx and the x location on every iteration. All right. And that looks pretty darn good. It goes up to 10 exactly, and it starts from 0.1. That's exactly what we're looking for, right? So we have some amount of confidence that this should give us what we want to see as an answer. So print out after the loop the value of the integral. Just say the integral e equals total area. Let's see what that comes out with. 398.849. So ideally it's 393 and a third, right? We're close, we're not there. It's with 100, it's with 100 rectangles. Let's, in theory, this should all just change automatically. So I'm going to put it at 10,000. What the heck? Getting darn close. 393 and a third's 393.333. Let's add a couple more zeros in. It'll take a little bit longer now. Got another for a few decimals. Got another few decimals accuracy there with I think about 10 million rectangles in there. So you start to see that this, if you could refine your rectangle choice, if you did a midpoint approximation, it'd probably be a heck of a lot more accurate. But it's called whole. But you can use this to integrate. Like you're actually getting the right answer out of this puppy, right? Which is super friggin' cool. Like we just have to change whatever that is, whatever function that we defined, and we can integrate whatever the heck that we want. Super fun. So yeah. All right, what do you got?
Undefined name total area.
Yes, so sorry, keep on saying I. Sorry, keep on it. Yep, and so yeah, the first time that you use it on line 28, it doesn't know what it is yet. Cool. Any questions with this? Cool. All right. Let's do this with arrays. Shush. Okay. So why do we want to do this with arrays? One, it's handy. Two, one example is when you get into more advanced finite element modeling and such, all these programs use numeric integration. Everything does it. Absolutely everything. Be it the reservoir estimation codes that the petroleum guys will use, or the finite element mechanical and aerodynamic and thermal solvers that the general engineers use. Everything does numeric integration. Question is just with what, really? So when you do that, it's really handy to have arrays, because of the different places that the values that you integrate will go. They won't, you're not just looking for the total area. You might be looking for the magnetic flux through a point, or the heat flux through a particular point. So I need to save the amount of work done at a point, or so on and so forth, so I can use it in a couple different places. So we're going to store, instead of just summing up the total area, we're going to save each incremental area, the area of each rectangle, in an array, and then we're going to sum that up separately. All right. So we know how to take the integral. So I'm just going to copy all that, dump it down here, and then I'm going to comment all this out so I don't have to worry about old code interfering with my new stuff. I'm going to keep all this stuff up top just so I don't lose the basic stuff, because I'm still going to have to know a dx. I'm still going to have to know my x-min, my x-max, how many rectangles I have, blah, 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 blah. I'm still going to have to know all of that. So difference is this total area thing doesn't exist anymore. That doesn't exist anymore. We're going to do it with arrays. So I want to store the area of every rectangle. Question is, how big does my array need to be? I want to store the area of every rectangle. In this case, I have 1 million or 10 million rectangles, right? Right. My array has to be n rectangles long. So for that, I need what you call the numpy zeros command. For that, I need numpy. So I'm going to import numpy. You always do it at the top because you only need to import it once. Import more than once. Might do some weird things. So just do it at the top. That way I also know where to find all the stuff that I've imported. So elemental areas, p.zeros. I'll make an array of zeros that is n rectangle long. This is a one-dimensional array because I've only entered one value in. So I'm only going to need one index in order to locate any element inside of this array. So I can come down into here. Now, instead of adding everything up, I'm just storing it in this array. So if I have an array that is exactly the number of rectangles long, and I have the area that I want to store in that array, all I need to know is where to store it in the array. So where should I store it? Where should I store my information in elemental areas? Is there anything that is going to tell me the address for that, or do I have to make something up? Okay. Okay. Let's call a whole. Well, I guess what I mean when I say make something up is make up a index that'll change each time I go through the loop. But in this case, I have something that changes, right? Which is what? Yes, I changes. Every time that I go through the loop, it starts at 0 and it goes to n rectangle, which is conveniently the exact same size as my array here, right? So I can use that to tell me where I am in that array, or where I should store things, especially because the first element in an array, the address to it's always what? 0, right? First element in an array, always address of 0. I starts at 0. Last element in this array is going to be n rectangle minus 1, right? Last value of I will be n rectangle minus 1. So this is perfect. So if I just say elemental areas, address I or index I, and just save my area there, I'm done. That's awesome. That was easy. Shush. Then I can just say after my loop, just sum up all the areas in elemental areas and spit it out. And let's just print off the elemental areas while we're there. That print there just puts a space between the two. That's all it does. You could really put one of those top and bottom if I wanted to be super snazzy, super snazzy. Wow, I am not spelling well today. Just updated some of my comments to match the new layout of the code. Right, so do that, wait for a minute. There we go. It can't print the entire array of elemental areas because it's about 10 million elements long, but you got a little sampling of the here, followed by the value of the integral. When you add up all those bits in elemental areas, you get 393.33, et cetera, et cetera, et cetera. There's also a fun little exercise in what if you have a whole bunch of small things and add them up? They actually become a big thing. Any questions with this? Cool. Well, that's pretty straightforward. So that's arrays for arrays for you. For kicks and giggles, let's just show how you do this with a for loop or a while loop. So instead of using a for loop to do this, you could also say while x is less than equal, what's called while x is less than x max. And instead of dx times I, you just add a dx onto whatever your last x location is. And if you do that, everything should work out to be the same as it was, well, previously, unless you forget to set your initial location. Initial location being X location. And then you have to do that, right? Okay, and then it's called, and now that you don't have I defined, you have to define that. Is there anything else I'm missing in this? No, that all looks fine. That should go second. So I starts at zero, set the I starts at 0. So anyhow, just wanted to do this to say that you can do it more than one way. The only problem with doing this And a while loop is exactly what that's saying. Saying that index 1 million is out of bounds means that I tried to access an array element that's not there. So I'd have to go back and play with my condition to make sure that I wasn't having it run one time too many, or based on where I put the update for the index I, that it wasn't going too high. So it's a little bit more work this way, but it is possible. Just wanted to show that. So might as well just fix it quick. That is the right one. There you go. You get the same answer. Any questions on all this? Cool. All right. It's about 2. The rest of the class is yours to work on your work.